Hello.
Hello.
Hello, Mr. Murray. I have a question actually. Can I ask?
Sure.
So I'm quite new to this ODSA link layer and transaction layer, for that matter, this die-to-die interface. So I was going through
Mhm.
the specification sheets. So in 5 specification, it says the clock domain crossing happens in link layer. And then in transaction link layer specification, it says the clock domain crossing happens in transaction layer. So what is the discrepancy? Could you please comment on that?
Uh, which clock domain crossing are you referring to in particular?
Uh, so like ideally it should be at link physical interface, right?
Okay. So,
S-
um, so yeah, so, so the perimeter between, well, so yeah, we don't really deal a lot with the clocks.
Okay, okay,
Trying to think about what the best way to answer this is.
okay,
Um, so yeah, so we're mostly concerned with the system interface. The
okay.
actual the physical interface there between the file layer and the the link layer. So the
Yeah, yes.
transaction link layer, there is a protocol boundary, like there's some packet formats that we kind of define between the two of them, but
Uh,
there's not a
uh,
physical interface between the transaction and the link layer. So and same for the protocol layer in some regards. So it's all kind of one thing. So like we have our transaction link layer spec, and the reason it's kind of
okay.
specified like that is it's kind of imagined to be one block. So
Okay.
and then the system level interface is just the bus interface. So whatever clock crossings you need to the system interface is whatever it is. Now the interface between the link layer and the physical layer, I'm not 100% sure.
Uh-huh.
So
So then ideally it should be between I mean it's safe to is it safe to say the clock domain crossing is between link layer and physical layer?
yes, absolutely. Now what side of the fence that's on, I can't remember exactly what that perimeter it looks like, or whether we even fully define that, say the truth.
Okay.
I
Okay.
think it may actually be in the bow spec. So
Uh-huh.
again, where you're putting that actual clock crossing, I think it might be implementation specific.
Okay. So actually in BOW specification it says there's a clock that goes from physical layer to the link layer. So that's where actually the clock domain crossing should be. Like imagining the transaction link layer as a single entity, basically.
Hmm.
Yeah. So in such case, yeah. Then thanks. Yeah. Yeah. Thank you so much.
Okay, glad that answers your question.
Yeah. Yeah. Thanks.
Okay, yeah, I think we have enough people on. We can go ahead and start with the TLL specs stuff. One moment, let me pull that up. And welcome to the call, by the way. Oh, I see Helia's on, and Jeff. That's awesome. Thanks, guys.
Hello.
Yeah. So yeah. Okay. So I I guess we had kind of a light call last week, and so I talked a little bit about you know um, closing out the rest of these comments and stuff. I think there's just a couple of things that are left on that side. And before we start, in case I forget, I'm going to be gone the next 2 weeks. So again, Helio, whatever you guys want to want to do in that time frame, it would be great. I think there's still a couple of opens here that probably should be addressed, either addressed or just decided to be ignored. So let's talk about those real quick. So there's still a couple of fix me's here. I think that's just a reference when we need to, whenever we're done with the references. Yeah, I left this in. I think, yeah, I again agree with David to remove that fix me. Same with these things. I think the only fix me that he was advising not to ignore, or there were two, or two classes of them. The oh, we're into the other stuff. The state diagrams. And we need to make a decision whether we're going to bother with those or not. And then sorry, where was the other one?
Is it the error probability table?
No, well, maybe, I don't remember, not specifically. It was something, there was one other thing. Um, So that's the state diagram. Oh, is this one right here? Um, the virtual wire behavior, and I don't know if anybody has an opinion on this. Um, uh, he's basically saying that the state machine for the virtual wires, there's an argument that it should be reset whenever you go through a disable. But he makes a point that, I guess that disable shouldn't affect the state machine. I wasn't 100% clear on why disable shouldn't affect the state machine. It doesn't seem like we're really limiting the state machine, the inputs to the state machine anywhere else. So, and he makes a point, it's probably worth a wider discussion. Again, I don't know if anybody has a strong opinion on this at all. I think it's probably something we should just decide yes or no on.
I guess you need further input from David or to explain.
I mean, he's kind of given his input.
Yeah.
He's just kind of left it open in case anybody wants to argue with him, but I don't think anybody's arguing with him. So we should just probably document that as such, unless, again, I'm throwing it out there in case anyone else has a strong opinion on this subject.
Looks good.
Okay, so I can add a sentence that just basically says the state machine is reset whenever the virtual wires are disabled. Again, I'm still really unclear why it wouldn't be, but again, throwing it out there just in case people have a strong opinion. I think that was the only real technical one that we had here. The rest of these are really just, do we want to add the illustrations or as he mentions the UML or what other representation we want.
So I think David himself is very tied up with few things. The illustration would be great. And I think he's the right person to add it to the spec. But if the timing doesn't work for him, which I understood that was the case, maybe we could just postpone it to 103 version. I think that was what Jeff also suggested earlier.
Yeah.
Okay.
Yeah,
I mean,
I'd be-
again, if nobody has time, I mean, I don't, like I said, I'm gonna be gone for a couple of weeks. If nobody has time to look into, to want to deal with this, then yeah, we can just delete these fix me's, I think, because they're not absolutely required. I just wanted to make sure that we made a decision as a group on that.
I'm sorry, does that include the state diagram one as well, or do you want to resolve that?
Yeah, I
one?
think that's the one we're talking about, really.
Okay.
Yeah, I think with the other one, we're just gonna add a sentence, but with specifically in the state diagram, do we want to just delay the state diagrams for another version of the spec?
I would. I don't think David's going to get to it. And if you can't infer it from the language, then, well, let's just wait.
Yeah, I mean, again, I don't know. I feel like I could probably do it, but I really need to have more hours than I probably to do it. Yeah. All right, so we can go ahead and probably remove those. On this one down here, I actually moved the register definition. I think we kind of meant to move it earlier and it just never got moved. So I moved the sideband error register right here, which is in this group here, but it wasn't, for some reason it wasn't moved earlier. So I moved it up here because it was causing some ambiguity. And trying to think of anything else. Helia, you have a couple of other notes in here. Was there still an issue with this one? I think you're making a comment around what the PMR table is. I think this is just similar to all the other ones that we have where we have the registers documented individually. And so that's all that table. I mean, no, it's got basically no information in it, but it is the, you know what? Is it because the identifier is missing? Because this is supposed to, maybe that's the confusing part.
I'm trying to see what is this table trying to show? Is it
It's just the same thing as all the other individual register tables. So we have these tables that say, all right, here is the, individual register, and it's the same thing. This is the PMR. There's no other breakdown of the fields in the PMR. So the table ends up being just one line and very simple, right? But it's just the individual register. That's it.
yes, and then later we explain the formats of the PMR and commands and all of those.
Correct.
Yeah. I guess maybe when I was going through that, I felt that.
Yeah, no, I understand there, since there's no breakdown in fields, it just looks like, oh, it's
No,
just
that makes sense.
saying it's
Yeah.
64 bits. Why do we care?
Yeah.
All right, I'm gonna mark that as resolved then. And then the other one here was, you mentioned that there is a mismatch. I think the point I make is that, yeah, the link control protocol only uses 19 bits of the address. The rest of the address bits are for the other things that you might communicate over sideband, because there's other register spaces out that are outside of the sideband.
Okay, so let's go over
Outside of link
this
control.
name, instance ID, register type. And then in table 1, how do we break the fields in table 1?
Now, this is specifically about the address bits. So this field is only 19 bits, right? For this is the address space. Sorry, I don't think this is a register. This is just the address space. And this is how the address space is broken down.
The address bits to access the registers.
Correct.
To address the register space. And then when we go to the, gonna open this on my side. I'm gonna try to open table 1 and see what was on table 1. Because I remember at some point we extended the address field, and I want to make sure that is aligned with everywhere through the document. Table. Oh no, table 1 is Reynolds. Okay, that doesn't apply anymore. Oh, maybe it's the table 1. This is in the link control. Yeah. Okay. So it's section 13.
So the bow sideband has an address space, right? Which I think is what you were referring to earlier. And
Okay.
it's
So
like
that's table
24 bits,
2
I think.
now. I think that's table 2 in the merge document. And yes, yeah, exactly. Now that is 24-bit address. And you're saying that this is byte address of the CSR.
So yeah, so the link control protocol is one of the things you address with the sideband protocol. And I think Ram made the point that, you're going to want to have other things you talk to, which includes like direct sideband controller, register access, and whatever else we add in the future, right? I mean, there could be an argument that this address space should be larger. I think, 32 bits or something, just so you can get native, 32-bit addressing or something of that nature. But I think we never really went that far. And it's probably better that, we're not, you have some sort of interface for the rest of the system that's probably not a direct address, for all the registers in the system. So that's fine. So 24 bits is, where we're at here. And then the comment here is just the link control protocol is only 19 of those bits. So you can definitely use those, that rest of the address space for whatever you want.
Okay, should we say which of the 24-bit maps to the 19-bit?
I mean, it's the LSBs, right? Since you're it would be the upper bits that are on it. You have to make an assumption about.
So a bit, maybe in table 2, we can say bit 0, bit 5 to
I mean,
5 plus 19.
it's an address space. I don't think you have to make any assumption there. I don't think you have to make any declaration there, because there are for the link control protocol. Again, you have to. There is an implementation specific piece here. You do have to define your sideband protocol address space, right? So that is part of the communicate. That is part of the things you have to know going across the link. What's your sideband control protocol space look like? You know, there's going to be a bar for the, not bar, but there's going to be a base address for the link control, right? So what are those, whatever those MSBs are, right? And the rest of the address space is defined here, right? I don't think we have to like make any big declarative statements about how this slots into that address space. Is it confusing?
To me, it is. It feels that that could be leaving things open that could cause issues unless we
So we don't
specifically.
have any kind of discoverability anyway, right? There's a bunch of stuff you have to know when you go across the link. And this is just kind of, we could mention that, like, you know, you do need to know what the base address is here. But I mean, otherwise it's not. I mean, of the things you have to know across the link, this is probably the least. You understand what I'm saying when you have to know,
Yes. Yeah.
you know, I
Yeah.
think with most implementations, it's just zeros or something like that, right? The MSBs are probably zeros. But again, I don't think I don't think this is not a,
Well, one thing here we make in table 2, we make this byte addressable. And that is what Paul proposed in table 3. Um, how to make byte word and so on addressable. But in the other table later that we only show 19-bit, is that that's not byte addressable? Is that's the whole register? Is that true?
I would assume all these addresses are byte addresses. As you're saying it's not?
So we extended few bits to allow us to make basically the length of the buffer encoded into the address.
Which protocol? In the
Uh,
sideband
The
protocol?
sideband, yes.
Yes, and you're talking about this table, this table right here, right?
Yes.
Yes, these are all byte addresses. Oh yeah, sure.
And the length of these addresses, these 3 bits, the last 3 bits are the 3 bits that we added. So these are added to the 19 bits of the register.
Yeah,
I
this
think
is
so.
just,
But this is for the sideband controller, right? So
Yes.
basically, this is for the sideband controller where you want to access the sideband related stuff, right?
Yes.
And assuming you're accessing the far side portion, and you have a set of register map that is being defined. So basically, this allows you to indicate the address that you want to access, as well as the transfer size that you would like to perform, right?
right. So
Yes.
the transfer size is implied by the address. right? So depending on which address you're trying to access implies your transfer size is what this table is saying. So there isn't a separate length field.
So now I'm looking at table 17. So I'm thinking that those 3 bits that we add in the table that you're showing, table
We're not
6.
adding, I don't think we're adding bits here. Again, I think those valid byte addresses, those are just the last 3 bit. Those are the LSBs of the address.
But the way that table 17 shows, I can map those 3 bits here.
What? Table 17, talking about the LCP. Again, this is just an address, right? It's just an address.
And then
in both cases, they're addresses, right? And so in some cases, depending on what your address is, you're giving a byte level. It's just, you need to, I guess, we need to mentally decouple these two things because one's on top of the other one, but doesn't have to be, right? So with regards to table 17, it's just an address.
that's an address, which
Yes, so
is not byte accessible. That's the whole 64-bit address.
yeah. It's a word, yeah.
Yeah, and then the 3 bits that we add,
Well, hold on a second.
will make it byte addressable. Now I'm still missing 1 more bit to make it 24. Or 2 more bits.
Again, it doesn't need to be 24.
This is 20 bits. This is 20 bits, 0 to 19. This is 20 bits. So 4 more bits. The 3 bits are the encoded length. And 1 more bit.
Encoded length. Again, those are just those are just part of the byte addressing. So you don't need to worry about the 3 bits of encoded length. They're not extra bits. They're just part of the address.
I think they're extra to this 20 bits. They can't be part of this address because all of the bits here are accounted for. If it is the way that
extra with over the 19, you're saying? Okay.
Over the 20. So this table 17 explains how we address.
Yeah, over 20, sure.
Yes. And then we add 3 more bits that we explain in table 2. Was it 2? That how the bytes or variable length are accessed. So that would be 23.
But again, we don't have to account for the whole address space. You don't want to account for the whole address space. Of the sideband protocol.
That is right. The whole address space is what can be accessed at 64-bit. The way that it is explained in this table 17. So 2 to the power of 20 is the maximum word size addresses that we have. But yeah, we don't need to account for all of them. And how we map the address to the physical registers are explained here. And then the 3 bits that we added, so this is the history. We were thinking of adding another field to say what is the length of our accesses. But then we settled on encoding the length with the actual byte location. And that is where the table 2 comes from.
Sure.
So that's the 3 extra bits that should show up whenever we, I think table 3,
Yeah, I see what you're saying. Okay.
whenever we make accesses, we just add those 3 bits. But then I'm looking at table 2, so we have those 20 bits, and then that are the word addresses, and then we have these 3 bits that are the, I'm going to call them length encoding, which is which place and for what size in that word is going to be accessed.
No, but sorry, but table 2 is a different topic, right? Table 2 is basically telling you from the sideband protocol perspective, right? When you want to send through the sideband how to say when you send the instruction across the sideband, right? The packet format that you're going to set up will be based on table 2, right? Basically, that's the 101 bits that you need to send across, right? Where the location 0 to 2 indicate the command, 3 to 4 indicate the length that you want to operate the message, right? And 5 to 28, which the 24 bits that you're referring to means that the address that you want to access based on the command that you send
Yes.
on bit 0 to 2, and then the data if you are performing the operation that you want, and the last part is the ECC, right? And the command is being defined in table 11, right?
That's right.
And then the table 14 that you are referring to, I have a feeling that is slightly decoupled from this table 2, right? Because the table 14, from what I read from the spec, is you are trying to say how you want to address the register that is defined in the bunch of wire, right? I mean, correct me if I'm wrong. Okay, so my understanding is table 14 indicate okay okay, sorry. It indicate that, okay, if you want to access what register, for example, the sideband register, the link control register, the link layer, link data register. So bit 16 and 18 indicate the register type, right? And then this is how you set it up. That's the reason. I think that's the reason why it was only 19 bits, because you only need to define what you want to achieve. Like for example, if you want to access a sideband register, right? So bit 16 and 18, you set it to 0, and it's a standard register. And then the instant ID depend on which portion of the instance that you want, and the name of the partner address, right? Which refer to the next table, which is the table 17. Is that my understanding correct?
I think so. Yeah, yeah.
And table 18 indicate what are the mandatory register address map that anyone that is using the spec need to support, right? Minimum, you must have the partner message, link state, link data, link interface, and the physical layer.
So these, as you said, table 16, the link state registers are part of the link control address space.
Yeah. So let's say if the link controller want to access the sideband, then basically it will have to set the corresponding based on the table 17 right now in order to go to the sideband related register.
So these will be added to the PMR register space.
PMR register space.
The PMR register space is how we partition based on table, where's it? Table 3, and then we say it's a bulk of 21-bit words, 21-bit address space. So that's the whole address space, and then the link
Again,
state
this is the
added to
sideband
that.
protocol. This is the
Yes.
sideband protocol. So this is for addressing everything all over the sideband. So it doesn't have anything to do with the link yet in the spec. So
Yes,
these are byte level addresses for addressing anything on the side over the sideband, right? And then down here, like you're saying, this is a different address space that is no longer byte aligned. You're saying it's word aligned, or double word aligned, actually, probably. That is that is addressing specifically just the registers in the link control space, right?
link state. Yeah, link state.
Sure.
Yeah.
Okay.
Yes.
So again, we
Yeah.
don't have to account for all of the bits here. I see what you're saying by the 3 extra bits. So if it's 23 bits, you still have an MSB you can do something else with on the
Yeah, I
sideband
think
side.
actually these are additive. There's 19-bit, so 20 bits for the state registers, the link state registers, and then 24 bits is another address space, not the state registers, which includes the PMRs and other things. So that's fine. Yeah.
Okay. All right. So I'm gonna go ahead and just resolve the comment. So
Yes.
it sounds like we're more clear on this. All right, I think that was it. Yeah. Okay. So it sounds like the only things left to resolve now, you had a reference you wanted to add there, and yeah, this is resolved too. I think there was some document references. Oh, and then the stuff we just described here. So I can add a sentence based on the virtual wires here, and then we can delete the fix me's here for now. I think there was some strike through fix me's and stuff that need to get deleted too. But I think that's it on the document. Oh yeah, okay. Anybody else have any other open issues in the oh yeah, sorry, one other thing. The version. Celia, did you see if we were supposed to remove the revision thing, or what we're supposed to be doing in terms of what the version numbers mean?
I got the information from Jeff. Maybe Jeff, can you elaborate on that?
Yeah, it looks like they've kind of changed the nomenclature. So I think that Rev A is the first digit in the version numbering. So it'd be, 1.2.0. The first indice or whatever, the first part of it is the major release. The second is the minor release number. And then the third is kind of a errata rev number.
Okay, so is there any statements in terms of backwards compatibility that we're making with these version numbers?
That I don't know.
So that was always how I reviewed the revision, because we were specifically saying, okay, well, we'll stay with Rev A. This will be the second version of Rev A because we're not Nothing's breaking, right? Um,
Yeah,
where this is all additive.
yeah, so A would become 1, right, in the first indice of that version number. So
And
in
this
the
Okay.
is
contribution, yeah, in the contribution presentation, I called this version 1.2.0. And then when we add the UCIe, it'll be 1.3.0 because nothing materially changes how we're doing all the encoding, right?
Okay.
Or yeah.
All right. So I'll go ahead and delete that. There was we had some comments also last meeting about the date and footer and stuff. So at some point we'll need to make sure that we get those updated too. I can go ahead and make some, you know what, let me, let's say TBD, July, whoops, 25, just so in case we forget. At least it has a month and a year.
so
Is there,
sorry, Brian, I didn't mean to talk about Jeff, regarding to the versioning, this is the new versioning paradigm for open chiplet economy, or for I'm trying to see how we can make it easier for and align with other work streams.
I got the sense that it was an OCP wide versioning that's been introduced.
Okay. And another thing is that we, again, regarding the versioning, it's ODSA. Should we remove ODSA and replace it with OCE since our subgroup name changed?
I mean, it seems to make sense to me, but I don't know. I don't want to make the final decision there, but
Yeah, like on this line that you were showing, Brian, the subgroup used to call ODSA.
yeah, 1 second. Let me make this change real quick before I forget. It's likely to change with major version release. Okay. Here, I think that might be, yeah. I mean, is OCE just interchangeable with ODSA? Can we just search replace that? Is that something?
That is my understanding.
or is it OCE-LL, right? ODSA, was it kind of confined to the link layer discussions or?
I think ODSA was really the OCP, the market study, the link layer, the bow. I think that the ODSA was the name of the subgroup. Now the name of the subgroup, I think, is OCP.
Yeah, I just think probably the scope has gotten a little bit bigger with OCE, but I think it's probably interchangeable, like you're saying, the terms.
Okay, there's some links and stuff too, so we'll have to, we can't do a blind replace. Okay, we can, here, let's make a note. Okay. I don't think I use OCP in here anywhere. Oh, no. Yes. That still stays the same though, right? OCE is still under OCP, and this license is all still the same, right? Open Web Foundation. Okay. Well, anyway, hopefully somebody somebody from legal will look at that when we we release. I guess this was all changed. All stay the same too, since we're still under the OCP, right? OCP template. Okay, that's all good. All right. Yeah, I can replace that. Anything else? Okay. Before we run into time, I guess other topics. So Jeff, any movement from your side on the streaming protocol?
Yeah, so we made the contribution. It was accepted by the steering committee. So I think it's going to get published here. I think we just have to confirm that we want to go ahead and publish, which means that I think the source document will be available to roll it into the spec.
Okay. Can you share that ahead? I don't know. Does publish mean share in this respect?
Yeah, I think it's actually goes into the OCP contributor directory or space.
Okay.
Should be publicly available there. And I can forward you the original, the contribution. if that-
Okay. Great. All
That
right.
would be great. Will you send through, if you send through email, could you include me as well?
Sure.
Thank
I
you.
mean, let's see if it can just get published, and I'll point you guys to it should be available in the contribution space, and let's just go there. If not, then I'll send a PDF version of it.
Okay.
Okay. And I guess, Brian, we can start working on that maybe when you get back, or do we?
Yeah. Yeah.
Cool. Okay.
So I like I said, I'll be gone the next 2 weeks, I think. So sorry, week whatever the week July of 20 so I'll be gone the 10th and the 17th. From a meeting perspective, I'll be back. I should be at the meeting on the 24th. So if you guys want to discuss and review that while I'm gone, I'd have no problem. I can just give you my questions when I get back.
I think it's super straightforward, so I don't think it'll take a lot of time.
Okay.
But who knows when we start discussing things. So.
On a similar note, has anybody heard anything about implementations with regards to the packet formats that we had discussed previously? Specifically the mixing of streaming alongside other flit types? Because that was the other kind of open thing in that discussion.
Yeah, so our contribution was focused on the raw format.
Sure. Yeah.
Yeah. And then I think we put a comment in there about if you go with this 256 byte latency optimized, I think that's the terminology they use.
Yeah.
Then what's going to happen is the CRC retry mechanism will make the corrections. So I guess the ECC forward error correction becomes just an overhead, right? And you can't utilize it. I don't know if there's a way to kind of expose the FEC such that you do that error correction before the CRC retime. I don't know if that's even possible, but that's something we can discuss going forward.
Right. Yeah, that was something also I discussed
Yeah.
during the flit discussion.
Right.
But that ends up being just a implementation detail.
So I tried to figure out why they use that flip format. I think it's because it's aligned with CXL, what the CXL protocol binding uses.
Yes, absolutely. It's the exact same one, and probably for the same reason we're talking about. If implementations only have one and you have to do the multiplexer based on that same format, then might as well do that. And on top of that, I think they did that just so they can keep some of the, like we said, the C, they don't have another level above that. So because that goes direct, there's a direct mapping of that into basically chiflets. And so there's not another mechanism above that for error correction. So they're just relying on the UCIE's error correction stack for everything.
Yeah, I mean, yeah, there may have been other motivations to select that, but and the thing is I don't think there's going to be concurrent CXL, behavior on the links. So I don't know if since this is like a boot configuration, I don't know if there's a problem if you break that if you use a different format than CXL.
I don't
So
No, I don't think there's a problem. I don't think there's a problem. Whether there's concurrent or not, I don't know. Yeah, I don't know. I don't know what, a lot of the stuff that they do, and a lot of the stuff this stuff was kind of designed for, at the end of the day, is not the device space I play in on day-to-day basis. So, while I've done some server stuff, I'm not a big server guy. So a lot of that CXL and a lot of these designed implementations are focused on the server side. So maybe there is some sort of implementations of storage controllers plus accelerators that makes sense to have CXL as a parallel data path with in a chiplet configuration. I have no idea. So so I can't really comment on that. But again, I think our motivation of whether or not we provide another flip format here is if there are existing implementations that they're already using this ARM stuff and they can't pick up any of our they can't use the transaction layer as is, multiplexed in that implementation without a lot of extra work, unless we also support that format. That's the kind of feedback I'd like to hear or not hear, if people know, so that whether it makes sense to go through the trouble of bothering with the flip format. I think I'd prefer not to. If we just have the streaming and people can just multiplex the streaming, then by all means, let's just do that.
Yeah, another question is whether the raw format is guaranteed supported by all PHYs, ESA PHYs. It's kind of unclear from the spec because it seems like it says if CXL protocol is not supported, then it is a mandatory requirement to have it. But in the case of if you have CXL in play, I don't know if it's guaranteed to be there.
I think all of well, yeah, I see what you're saying there. I think for the most part of the market, the places that we would be playing in, streaming is supported, raw streaming, because all of the other controllers I am aware of, and that are trying to transport AMBA or whatever across the link, anything that's not PCIe or CXL, they're relying on that. And so, the vast majority of controllers are going to have an option for that are playing in this space. That said, again, I'm not in this server space. There may be a whole category of IP there from server chiplet stuff that I'm not aware of, that again, maybe like you're saying, ARM is using that information of available IP to drive their decision for the Chai stuff too, which may reinforce that decision.
Right. I mean, Chai chip to chip is, this other flip format, not a raw format.
Right. It's on that. It's on the same 256 byte. So again, maybe they only did that because the space they were looking at, that was the only supported format.
Mm.
But again, I'm not looking at those same IP providers.
Mm.
Anyway, if we can get more, if anybody has any methods of getting more market feedback on that, that would be swell.
Sorry. Actually, just to check with you, the topic that you are discussing right now is related to which portion? I'm a bit confused here.
Sorry, this is probably a discussion that we had started before you came on board, David. So we're, for the next version, not this version of the transaction link layer, we're looking at adding another appendix or chapter that talks about mapping the transaction link layer onto different phi layers. And so the first and only current proposal right now is UCIe. So we would map the transaction link layer on top of a UCIe FDI. And so, and then the question is what format do we use when mapping it onto UCIe? And there's two options that we discussed. One was a raw streaming interface, which is Ventana will be donating an implementation, a proposal for an implementation that they had done that covers the streaming side of it. And then but we also discussed the fact that there are other similar protocols out there already that are mapping on UCIe, specifically the ARM CHI mapping. And the ARM CHI mapping to UCIe utilizes the 256 byte, as Jeff said, latency optimized. There's another couple of words, flit format that basically maps a CHI flit onto that specific 256 byte flit format. And so the question is, there's an open question about whether we also support that, because that's the direction ARM chose, and we could match up with a similar implementations, or again, they chose that because of market information, like we were discussing.
Oh, okay. Thank you.
Is this at physical layer that we kind of interoperate, or is it
Kind
higher
of.
levels?
I mean, it's UCIe, right? So
Yeah.
UCIe has a physical layer interface called FDI. And I think I'm saying the right acronym here.
Yeah. It's the flit aware interface.
Yeah. And so it is the physical interface, but UCIe's definitions are a little bit different. So it's kind of they do handle some link state stuff in that interface as well.
Mm-hmm.
So but it is a wire interface between the higher levels of the link and protocol, the protocol layer, and the lower levels of the link and the physical layer.
Okay. Yeah. Thanks.
And I think, as we discussed as well earlier, there's differences in assumptions between our transaction link layer and our physical layer, and the assumptions that are given for a similar mapping when talking about the UCIe physical layer. And hopefully the Ventana proposal will handle some of those changes in assumptions, including byte orders and orders of transmission and things like that. All right, looks like we're out of time. Anything else before we close, guys?
Brian, regarding the schedule, so I think we are ready to start with the approval process. You said you're gone for 2 weeks. The first step for us is to present this document to the Friday meetings at the OCE level. So Friday 25th might work. I can start a conversation with Anu and Jawad to get on that day schedule.
Should work. Let me check my calendar. Just making sure.
That's
Yeah, I don't see
July
anything. I don't see anything
25th.
blocking me right now for July 25th. Is there any kind of so we presented at the meeting. Is there like a comment period after that?
No. I think you're just going to present it, you get the go ahead, and then you have to go present to the server project. And then there's a review period there where you go back and forth on the contribution and content. And then it gets eventually approved by the steering committee.
Okay. Yeah, I can present on the 25th if you'd like. One other thing in the document, there's a list of like companies and editors and stuff like that. Is that something we should also change in advance of that?
Yeah, I think you had a set of new people involved, right?
Celia, are you still on? Oh, she lost her audio.
I assume you have to update that list, or you should update that list.
Yeah, I have a note in there about whether Rom and Paul need to be included in the author list as well. I have the 3 editors that worked on the sideband protocol, myself, Helia, and Boppy as editors, quote unquote. And then Rom and Paul both made significant contributions as well in terms of like volume of text. So, but I have a note in there whether they need to be added as authors or whether their companies just need to be included in the license or whatever. So I think there's
So I
a
think
couple of
Paul will we can add all of their name, but I got their feedback how they want to be represented. They're representing their companies or just self. Sorry, my audio just was gone for past few minutes. So July 25th would work. I lost all of those conversations.
Yes, July 25th is fine with me.
Okay, and then we'll take it from there.
Yeah. So I guess there's two things the documents in terms of names and companies. There's an author section, right? And I have the 3 editors in there right now. And then, but again, whether Rom and Paul need to be included in the authors or whether anybody else's name, I guess is a question, right? And then the other
I think
question was
definitely both
whether we need to
because
add any companies.
I think Ram and Paul both because I remembered some tables that they have contributed.
That
at
they
least.
both gave significant amount of
Yes.
text.
Yeah. Yes.
Yes.
So definitely those. I don't know if we add or how we add companies. I give
Well,
the name of.
there's a list of companies in the document. 1 second. Ventana, Blue Cheetah, Dream Big, Verisilicon, NXP, and D-Matrix. I know there's other companies on this call that have made comments, and then there's other companies that have come and gone, or on occasional calls, like Infineon and things like that. So the companies like that, that I don't know whether, I assume since they've made comments, they have to be included as well, and we have to get their clearance too.
So I gave a list of all the people that I knew have contributed to the lawyers on this version.
Okay.
Um,
Does that
I would-
include the people like on the call right now? Like,
so Bunchang is there in that list.
is David's
I
company
can-
on that list?
Yeah, I can add David
And
and many sorry.
It's Manikanda. I have been
Manikanta.
just, yeah.
yeah, and like I said, I think Infineon's also been coming to recent calls as well too.
Okay. So let me think with you offline to generate that list, and I'll show you the list that I shared with the with OCP folks as well.
Okay.
Okay, and July 25th we'll get on their schedule. Okay, thank you.
Thank you.
Mhm.
Thank you.
Bye.
Thank you.
Bye.
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 Bye.